The topic to be presented is real-time operating systems for networked embedded systems. A system is said to be real-time if it is required to complete its work and deliver its services on time. So the example is flight control system, in which all the tasks in that system must execute on time. Non-example is PC system. And the other live example is fire alarm system, which is required a central server, TCP or IP over radio, controllers which is ARM based, low bandwidth radio links, sensors and microcontroller based. In fire alarm system, what is the problem is detected is the live performance is very important. When the fire which is detected, it should be sorted out at the right time. So hundreds of sensors each fitted with low range wireless is to be required. Sensor information is to be logged in a server and appropriate action is to be initiated. So how to solve this solution problem is taken into account. So routing dynamic sensors is used, auto configurable, and less collision is taken into account. Also less number of intermediate nodes. So target architectures is RTOS, real-time operating system, processors MIPS, microcontrollers ARM7 or ARM9, strong ARM, Intel Exasol, mix MIPS 4K score, Core x88 is used. Then the presentation outline is, first we are going to see about the definitions, then role of an OS in real-time systems, features of real-time operating system, in that scheduling, resource allocation, interrupt handling and other issues. First, hard and soft real-time systems. Hard real-time system, failure to meet deadlines which is fatal, and the example is flight control system. Soft real-time system is late completion of jobs is undesirable but not fatal. System performance degrades as more and more jobs miss deadlines. Online databases. Continue with that. Hard real-time system is validation by probably correct procedures or extensive simulation that the system always meets the timing constraints. Soft real-time system is demonstration of jobs meeting some statistical constraints suffices. Examples: multimedia system, 25 frames per second as an average. What is the role of OS in real-time systems? Standalone applications. Often there is no OS involved. Microcontroller based embedded systems, this we can tell as standalone applications. What is a real-time applications and why it is huge and complex? Multiple threads are to be used, which number of memories are required, complicated synchronization requirements, then file system, network, windowing support. OS primitives reduce the software design time. Features of real-time operating systems: scheduling, resource allocation, interrupt handling, other issues like kernel size. Scheduling in RTOS, more information about the task are known, number of tasks, resource requirements, release time, execution time, deadlines. Being a more deterministic system, better scheduling algorithms can be devised. Then continue with that. First, the requirement is clock driven scheduling, weighted round robin scheduling, priority scheduling. Now, what is clock driven? All parameters about jobs which include release time or execution time or deadline which is known in advance. Schedule can be computed offline or at some regular time instances. Minimal runtime overhead, not suitable for many applications. Next is, what is weighted round robin? Job scheduled in FIFO manner. Time quantum given to jobs is proportional to its weight. Example uses high-speed switching networks, QoS guarantee. Not suitable for precedence constrained jobs. For example, job A can run only after job B. No point in giving time quantum to job B before job A. It is first in first out manner scheduling. Next one is priority scheduling, which is also called as greedy or list or event driven. Processor never left idle when there are ready tasks. Processor allocated to process according to priorities. The priorities are static and dynamic. Static is at design time, dynamic is at runtime. What is priority scheduling? Earliest deadline first, EDF. Process with earliest deadline given highest priority. Least slack time first, LSF. Slack is equal, which is also called as relative deadline or execution which is left. Rate monotonic scheduling, RMS. For periodic task, task priority inversely proportional to its period. Next is resource allocation in RTOS. Resource allocation. The issues with hazard scheduling applicable here. Resources can be allocated in weighted round robin, priority based. Some resources are non-preemptible. Example, semaphores. Priority inversion if priority scheduling is used. Now we can see in the pic priority inversion. Task A required which is to be performed. Next it goes to task B. After that task C, which is the first signal it executes. That is called as a priority process. Solutions to priority inversion. But when the inversion happens, it gives a problem. Hence, how to solve this priority inversion is first is non-blocking critical section. Higher priority thread may get blocked by unrelated low priority thread. Priority ceiling. Each resource has an assigned priority. Priority of thread is the highest of all priorities of the resources it's holding. Priority inherence. The thread holding a resource inherits the priors of the thread then blocked at that resource. Other RTOS issues are interrupt latency is very small. It should be maintained very small. Kernel has to respond to real-time events. Interrupt should be disabled for minimum possible time. For embedded applications, kernel size should be small, should fit in ROM. Sophisticated features can be removed. No virtual memory, no protection. Interrupt handling problems